We're going to do a little series here on using BreakingPoint to create not only test traffic, background traffic, but also actual attack traffic in a CyberRange sort of situation. Basic idea in a CyberRange is you've got a blue team and a red team. And these are usually humans. The humans are attacking each other. The blue team is defending a network that's been set up, sometimes a VM network, sometimes physical. And then the red team is coming in and attacking that network. Typically, you may have some contrived situations where certain applications are in use that have vulnerabilities. The blue team is basically attempting to figure out what is happening, and the background traffic, also called the haystack, is being used to hide the attacks that are coming in. Now, BreakingPoint obviously can create massive amounts, a massive haystack, and it does get used in a lot of CyberRange applications. And this is typically with the military. There are commercial entities out there that are also doing CyberRange. I think I've heard of a handful. And what I'm going to do here is simulate some of the things that a human attacker, that human red team, might be doing. The idea is to create, at least to some extent, an automated CyberRange where the red team, where there isn't a human red team, but in fact just BreakingPoint. And so the first thing that we could do, the first thing that I'll show is a port scan. And this is under Session Sender, so let's take a look at the setup. Now what I've set up here is the port scan is coming from an infected client and it's being sent out to a second client. So you've got different options. You could have the port scan come from an address that's external to the network. And so, for example, packets could be coming from an address in another city or in another country. Now, but they should wind up at a server that's on a server or client, a host that is on this network. Now, in this case, I'm going from an infected client, meaning there's a host on the network that's already been infected with malware, and so malware is then sending information over to a second host, sending packets, trying to figure out what ports are open. And this is the sort of thing that could be happening once a network has already been under attack, and might be a different scenario than your blue team might be expecting. And so let's just take a look at how to set up this test. I've got it set up for a minute, and so I'm going to leave this set, but what we want to look at is, I'm going to go straight down to the bottom here. In a automated CyberRange, just overall, you may have several different attacks that you're going to set up. These attacks, each would be delayed by a certain amount. So maybe at 1 minute, some event takes place. Let's call it an nmap scan. And then at 2 minutes, maybe the second event takes place. Let's call it our port scan. And at 3 minutes, some other event takes place, exfil, where data is actually being sent from a host out to an external server that's waiting for that data. Exfiliation, in other words. So those are delay starts you would be using a lot in a automated CyberRange setup. And to be sure, with BreakingPoint, we can't really do everything that a red team can do. There's lots and lots of things a human red team can just do just about anything. So, there's limits to what we can do in terms of replicating that human red team, but there are some things we can do. So it's kind of would be good to set some of that up. That's what. So I'm going to leave this at a minute. However, what I've done here is I've gone in, and this is all ramp. So 0 steady state, 0 ramp down. This is just for the port scan. The port scan is basically going to send a bunch of SYN packets out. And then we'll find out what happens then is you look for responses, and when you get responses to the SYN packet, when the attacker gets responses, then you know that those ports are listening and may be open to attack. And we'll see this in the PCAP file when I run the test in just a minute or two. Now, related to that, let's slide down here and find the retries, which I probably already know. There it is. Let's see. Retry count. Set this to 0. Its default is 3, and in a realistic port scan, you don't want it trying over and over. It's just going to try each port address once. What I also have set up is up here my ports. I set these for random, and then 22 to 60,000, and that's you could go to 64,000, and you can start at 22, start at 1024, whatever range you want. But I'm sending out a lot of SYN packets to a lot of ports, and of course the IP address they're going to is client 2, which is just something you set up in your network neighborhood. The traffic will appear to be coming from the infected client, an address that's already in this network, but BreakingPoint will be sending that traffic. Now, that means that your switches need to have promiscuous mode set up so that your traffic will get to where it needs to go, so that the network will see traffic that looks like it's coming from this source IP address. And by the way, setting promiscuous mode on your switches in the network is very helpful. You're going to need that for multiple CyberRange simulations that if you're doing them with BreakingPoint. One last setting I've made here. This is a low data rate, 1 megabit per second, and also max superflows. Simultaneous superflows I've set to 1, and that kind of keeps things looking realistic. And beyond that, I think that's everything. I'm going to return, and this is the only test I have turned on here. Let's hit save and run. Wait a minute. Let's go, since I'm using VE, and I always forget to do this, I'm going to, let's see, I'm going to enable, it's already enabled, good. And now I'm going to go back and I'm going to run that test, and then we'll take a look at the PCAP file, save and run, and I'm going to pause till we're done here. So that test is done, and let's export and then take a look at our PCAP file that we just generated. And so I paused there again. I've done this search. This is the address of client 2. Could search for either this or the infected client, and so that narrows down. In the original PCAP, I wind up with lots and lots of network management traffic, which don't really care about. It just happens to be on the same subnet in this particular setup. Now, here is the This is the source and destination, TCP, and SYN. You see the port IDs and just lots and lots of SYN packets. And theoretically, I don't have 64,000 in here, but you could have that many. And so this is what it looks like. So by getting rid of retries, I'm not just filling this with the same SYN messages over and over. It's just sending SYN, and it's 230 to 231, and so this kind of looks like a port scan. And in general, we're seeing that there are no ports in use. There are no ports being listened on, because right now, well, 231 doesn't exist. For that matter, neither does 230. They're on my virtual network on the laptop, but in a real network where I was doing this, you would see some responses on ports that are where listening is taking place. So the next thing we're going to do is an Nmap scan. Now this is I'm still on version 8.1. To do the Nmap scan, this particular customer was wanting all of the IP addresses to come out in sequential order, which happens to be a new feature added to 8.10. So I'm going to switch over to 8.10, and then we'll do an Nmap scan. In real life, the Nmap scan would probably come first. You'd hit a subnet with an Nmap scan, look at 254 addresses, come back and go, well, these addresses have something on them. Let's start doing port scans. And so that would be the real order that you would see things in. But for purposes of this video, I did the port scan first, and Nmap scan will be next.